It's certainly possible to add too much animation to applications. You could have icons that grow when you hover over them, logos that spin, text that slides into place, or buttons that bounce. No one likes that much animation. But animation has its place in interactive, rich applications. And it can also be used for bringing attention to important application content or guiding a user through your application. Animations are central to XAML-based applications, and they don't need any extra coding or manual manipulation. There's no need to do stuff like create timers and change attributes at regular intervals to create animation in XAML-based applications. You simply use XAML markup. You declaratively set up and initiate animations. And this is a huge topic. We can only cover the basics here, that is enough to get started. Both Silverlight and WPF support animation in the same way. WPF supports a larger set of tools, and in this section we'll be covering the smaller subset which corresponds to what Silverlight supports, so that in this section and the ones that follow, you'll learn enough to get started, but you can dig in deeper if you want to learn more about the specific details. You probably think of animation as a series of frames, kind of like a cartoon. You move through that series of frames, and the variation of those frames over time gives the effect of motion. Movies and cartoons in real life work that way, but that's not the way XAML animation works. You're not creating a series of frames and just animating through them. Instead, XAML animation revolves around changing a single dependency property over time. You might, for example, change the width of a button from 30 to 100 over a period of 10 seconds, or change the position of a gradient stop from 0 to 1 over a period of 5 seconds. The trick is finding the right property to change and the time over which you want to change it. Now, there's a limitation implied here. That means you can only animate a dependency property's change over time. Anything else, you have to resort to manual coding. You can't add or remove elements as part of an animation because all you're doing is animating a single dependency property's value. Also, animations are time-based. If the entire application depends on animation, you might want to think about some other technique, perhaps using a media element to display media. Because if that's what you're doing, you're more likely to want to store your media separately and just display it as part of your application. Well, let's think about the rules of animation. Animations act on properties. You can only do one thing: change the value of a single dependency property over time. That's all animation does. You specify the starting and the ending value, and the animation handles getting the value from one end to the other of that value. It sounds very limiting, but in practice it works quite well. Animations are time-based. You indicate the initial state, the final state, and the length of time, and the rendering engine takes care of the rest, getting you from one to the other over that period of time. It calculates the frame rate to create a smooth transition. If you're going from a value of 1 to 100 over a period of 5 seconds, you have a different frame rate than if you're going from a value of 1 to 100 over a period of 100 seconds. Things change differently depending on that period of time over which we're changing the value. More rules. Animations require specific classes, and classes are tied to specific types. For example, to animate a button's width property, it's a double, you'd use a double animation class. To animate a color, you would use a color animation. To animate a point, for example, to move something from one place to another, you'd use a point animation. You can also create your own animation class. All you have to do is derive from system.windows.media.animation, and you have to indicate how the property changes over time. We won't cover that advanced topic here, but I just wanted to point out that you can. So let's start with a simple animation. Maybe you want to create an animation that moves a circle from left to right across the screen. As it moves, it increases its size. The steps would be to create an animation object to perform that animation, create a storyboard to manage and begin the animation. The animation just describes what you want to do. It's the storyboard that makes it happen. And you have to create an event trigger or start the animation in code. Something has to cause the animation to start running. Well, let's try a demo which shows off a very simple animation. In this simple example, my markup contains a canvas and within there an ellipse. The ellipse is set to height of 100, horizontal alignment left, all the properties that define it. The only one I really care about is the name, which is circle here, because I'll need to refer to this control from my animation. Well, let's see what the animation looks like to start with. If I run my project, we see an animation which takes an ellipse from a certain width to a bigger width over a period of time. The world's simplest animation. Let's see how that one is working. Here, we take the ellipse, and we don't have any indication in the markup for the ellipse that anything's going to happen to it. But you can see up here a double animation element defined which says we want to take some property from 100 to 200 over duration of 5 seconds. You can see that that's pretty clear. It doesn't indicate which property or when to start running. So the instance of the double animation class that you create here only indicates to take a value from 100 to 200 over 5 seconds, but doesn't really say what property of what object and when to run it. That requires a storyboard. And you can see the storyboard element here, which contains that animation, indicates the target name and the target property. The target name is circle, meaning this ellipse, and the target property is width. Now, since we're animating a double here, because we've got a double animation, it's important that you specify a property which does contain a double. Otherwise, we get a runtime error. Now, that's the storyboard that defines what we're doing to what, but it doesn't indicate when to run. For that, we need an event. The event we're handling is userControl.loaded. Here we have a routed event attribute of an event trigger. An event trigger runs, without having to write any code, in reaction to the specified event here. So when the userControl.loaded event occurs, this event trigger will run. The begin storyboard element indicates that you want to begin running whatever it finds inside the storyboard. This storyboard contains one or more animation elements, and each animation can only animate a single element. And each animation can only animate a single property. So you could have multiple animations inside a single storyboard. In any case, here's what happens. The userControl.loaded event occurs. This event triggers. It begins the storyboard. The storyboard says, I want to affect the circle, modifying its width property, and the double animation inside animates a double value from 100 to 200 over a period of 5 seconds. That's how the markup can indicate exactly what to do as part of this animation. If I run it again, we'll see that ellipse change from a width of 100 to a width of 200 over a period of 5 seconds. It's the world's simplest animation example, but it does demonstrate the basics of building an animation in WPF. Let's review what we've seen so far. The sample includes the following double animation element. You can see a double animation from 100 to 200, duration 5 seconds. That takes some property from 100 to 200 over a period of 5 seconds. Now, there are several different types of animation classes. You can have linear interpolation, which changes a property value varying smoothly and continuously for the duration of the animation. That's what we saw. Double animation, point animation, color animation, and more fall into this class of animation classes. There's also keyframe animation, where values can change abruptly or smoothly, and keyframes determine specific states at specific times. There's a double animation using keyframes class, a point animation using keyframes class, and so on. we'll look at an example working with keyframes later on in our coverage of animation. WPF also adds path-based animation. There's a double animation using path class, a matrix animation using path class, point animation using path class. These allow you to animate a property along a physical path. You can move things from one place to another along a known path. It makes it possible to move a shape from one place to another, not just from one point to another point, but along a particular shape or path. That's not available in Silverlight, but you can play with that in WPF if you like. The double animation instance that you saw smoothly and continuously varies a property from 100 to 200 over a period of 5 seconds. But what property of what object? That requires another element, the storyboard. The storyboard class controls animation, providing a timeline for its behavior. You use a storyboard to group animations, to control the playback of animation, and to pause, stop, or change the position of an animation. It provides target name and target property properties, and these indicate which element and which property of that element should be animated by the contained animation or animations. In Simple Animation 0, this is the storyboard you saw. The target name was set to circle, the target property was set to width, and the double animation inside that controlled the value from and to we were animating with. We also indicated in the animation what the length of that animation was. The storyboard indicates that animation applies to the element named circle and modifies its width property, and the storyboard can contain multiple animations. Now we had to have some way to cause the storyboard to play. To cause the animation to play, we need some event that triggers the storyboard. An event trigger is a likely place to do this, and you could also use an event handler in code, and we'll see an example of that coming up. The begin storyboard element causes the contained storyboard to start, to begin running. You place that inside an event trigger element which handles some routed event. The sample uses the userControl.loaded event to trigger the event trigger to start the animation. And the code for the event trigger looks something like this. You have the userControl.triggers outer element, then an event trigger whose routed event attribute contains the name of the event you're triggering on. That contains the begin storyboard element, which contains the storyboard, which indicates which property of which object to animate, and then the animation itself indicates the time over which you want to change a property from and to. Our example showed only the begin storyboard element, but you can declaratively use other actions such as pause storyboard, resume storyboard, and so on from within your trigger. You can also write code to handle these, and we'll show an example of that later on. Our example uses the userControl.loaded event for the trigger, but other events work as well, and we have examples of that coming up later on as well. What if you need to animate multiple properties? You can include multiple animation elements within a single storyboard. Each animation element corresponds to a different property. But you can't provide multiple animations for the same property in one storyboard. That's a limitation of the technology. How do you indicate the property to be animated if you're using multiple animations? Currently, in our previous example, the element and the property were defined at the storyboard level, not at the animation level, so we have a conundrum here. How do we solve this? The answer is simple. All you have to do is take the target name and target property properties and treat them as attached properties. Supply them for each individual animation rather than at the storyboard level. Let's look at an example that has multiple animations and moves the target name and target property properties to the animation element rather than placing them at the storyboard element. In this example, we're going to animate the width, the height, and the left position of an ellipse. See what that looks like. We're modifying 3 different properties as part of that animation. Let's try it again. Here we go. width, height, and the canvas.left property of that shape. So how are we doing that? Let's go look at the markup for this. Here you can see, again, the same ellipse we saw in the previous example named circle. Here inside our begin storyboard element, within the storyboard, which doesn't indicate any target name or target property, we see 3 double animation elements. The first double animation element animates a target named circle and a target property of width. You can see we're going from 100 to 200 over 5 seconds, just like in the previous example. We're also taking the target named circle and the target property height and going from 100 to 200 over 5 seconds. So we take our circle and maintain its circularity. Finally, we take the target name circle and its target property is canvas.left. We go from 10 to 300 over a period of 5 seconds. Now the time periods don't have to match. They can be completely different durations. Obviously the values from and to don't have to match exactly either. It is important to note that the target property canvas.left is an attached property, and you must place it in parentheses to indicate that it is a single property value, canvas.left. To the parser, it needs those parentheses to understand how to work with that property. Now this attached property syntax is more common than not because it allows you to animate multiple properties concurrently. One thing you have to note is you can't have multiple animation elements for the same property. That would be impossible for the XAML parser to completely get right, and so they just don't allow it. One thing to note though, since the target name here is the same for all of these, you could have factored it out and place it up here at the storyboard level and just set the target name property there. Most of the time, you won't do that because you might want to change it to animate some other object, then you have to refactor the code again. It's easier to use storyboard.targetName here in each of the animations than have to worry about changing it later on. Of course, there's no rule that you must react to the loaded event in your trigger. What if you want to handle a click event instead? No problem. Just move the trigger to a button control and handle its click event. You may find that you'd rather write code instead, as you'll see later, but you can use a different trigger. Let's look at a simple demonstration that points out how you can use a button click to trigger an animation without writing any code. In this example, I'll trigger the animation by clicking this button here. When I do, we'll get the same effect as in the previous demonstration, but it doesn't start until I actually click the button. Click the button, the animation starts. It looks exactly the same as the previous animation, except the circle is blue. I wanted to keep you interested by changing colors. But if we look at the markup for this, you'll see it is slightly different. Rather than having an event trigger based on the user control, we've put the button.triggers element inside the button itself. We could have made this a resource outside of the button, but since it applies only to the button, it makes sense to put it inside the button itself. So here we have button.triggers, an event trigger, where the routed event is button.click. We have event trigger.actions inside that. We haven't seen that element before, and actually, since we only have the one action here, it's not required. We have a storyboard. Within that, the exact same animations we saw earlier. So we've moved the trigger to not be on the usercontrol.loaded event, but to be on the button.click event instead. We've placed that inside the button itself. Here's where I get a little weird. We could do this on an event trigger for the button. But look at all this typing you have to do. It seems to me that the single line of code we'd have to write to trigger this from event procedure in program code is actually easier than doing it here at an event trigger. So unless you just don't want to write any code, I find using triggers sometimes more overhead than necessary. You'll have to decide for yourself. But I haven't written any program code here. Everything has been done declaratively in the markup for this application. And we've, in this case, triggered the animation based on a button click event.